scores on the base model, and then we'll do the fine-tuning, and then we'll run the exact same input sequence and compare, how did those attention scores change. And we do the comparison across individual attention heads, across all of the attention heads in the aggregate, because most of these models have a lot of attention heads, and we want to look at differences across layers. We'll see why in a minute. So this is a standard attention matrix that you would see in any model when you just expose the attention matrix. And so these numbers here are telling you, effectively the rate of utilization of these tokens in latent space. So after we do the fine-tuning, we can compare, how did these numbers change? So this is Mistral 7B. Let's say I do fine-tuning and instruction fine-tuning. If I feed in the exact same text sequence, these numbers are going to change, and I can compute sort of like a matrix of differences, before and after fine-tuning. And this matrix tells me, it helps me isolate the impact of that training and fine-tuning, basically. And so here's where we can really begin to evaluate, the impact of your domain fine-tuning on, on your LLM. So one interesting thing I found, and first we need to observe that in many cases in the real world, specific concepts are made up of a series of multiple tokens and subwords. So it's never really going to be the case that that only one token is sufficient to explain a concept like in the legal field, like notice of retrenchment, which stands for a very specific thing, but it needs to be sort of made up of many different tokens in sequence. But when you look at what the effect of that fine-tuning was, you can see that only the first two tokens in that sequence were altered by the fine-tuning, and then the second half of that sequence, there was basically no effect after the fine-tuning. So this is really bad news if, for example, I am an attorney and I deal exclusively, for example, with notices of retrenchment. So this has shown me that if I've done this fine-tuning on this huge legal data set, it's actually not improved or changed its understanding of notices of retrenchment in any way. It does, sort of pay more attention to, the word notice, but not retrenchment, and certainly not, as an uninterrupted contiguous sequence of tokens, which will have implications on my task. This is another interesting way to look at, the effects of fine-tuning. So let's let the x-axis be the layer depth, so different attention layers. So we have, different depths of the layers. 0 is like the early attention layers, and 30 is the latest attention layer. And then the y-axis is the average increase in attention toward those domain concepts across all the heads in that one layer. And when you plot that, you get something that looks like this. So the red line is the impact, is the attention change from the base Mistral 7B after both continued pre-training and IFT. And then the blue line is just what happens when you stop at continued pre-training. And there are some interesting observations. So the first is that very similarly across many of the legal concepts, when you look at the range of values that the attention changes take, it's very small. It's like within